I'm going to assume that everyone has some basic knowledge of how to use Fusion 360 or like just CAD. But I'll just do a quick run through of how Fusion 360 sort of works. And then uh, if you have Fusion 360 installed, we're going to do a little test build and have you follow along with that. So this is about what you should see when you first open up Fusion 360. You have your projects on the left-hand side where you can create new projects to hold your files, different folders, and share it with your team members so that you can all work on it together. And then here in the main space, you have your workspace where you would insert all your files or create custom models. And now I'm going to explain how to do that. So the first basic thing of all 3D modeling is creating custom parts. So in Fusion 360, it's really simple. You go under the Create tab, and then you can choose from a list of boxes, cylinders, spheres, or toruses. The main ones that we use are boxes and cylinders, just because they're more convenient to use. But you can also create your own custom shapes using the create sketches. So for example, if I chose to create a sketch, I could select one of these planes, X, Y, or Z. It doesn't really matter. And then from there, it would bring up another create tab where I can choose from any of these shapes. And usually when you're creating a custom part, you would just use the simple line tool. And this will allow you to create different shapes that Fusion 360 doesn't automatically provide. So just something like this. But you can see that right now it's a 2D shape. So you would click Finish Sketch. So there are two ways to make it into a 3D shape. The first is under Create, it's called Extrude. This will, after selecting a plane or a face, you can drag the face up or down depending on whichever direction. The second way is press pull. It's sort of similar to Extrude, but it's a little less convenient. But it does allow for, you can use it to, well, Extrude can only be used on flat surfaces like faces or planes and that sort. But with press pull, you can change the size of a hole. Like for example, in this photo over here, you can see how by using the press pull function, you can shrink or expand the size of this hole. So I guess I got a little too far ahead. So if any of you guys are beginners with Fusion 360 and have never used it before, the way I'm making the view change is by clicking my middle mouse button. It might be different for you, and to check what your keybinds are, you can go up to the top right to your profile where it has your initials, click on Preferences, and then it should automatically take you to this page. And where it says Pan, Zoom, Orbit shortcuts, you can change it to whichever one you want. I use SolidWorks because I'm just used to that, but I think the default is Fusion. So in this case, clicking the middle mouse button or the scroll wheel would pan it, and to rotate, you would do Shift plus the middle mouse button, and then just drag your mouse. Okay, so after creating a model, there are a bunch of different tools in Modify that are sort of useful, like fillet and the chamfer function. And these fillet rounds, edges, And then chamfer does a similar thing, but instead of rounding it, it bevels it. Shell is really useful when you're creating a box and you're trying to make it hollow, and it's just a shorter version of emptying it. So for example, if I just had a random box here, instead of creating another rectangle here and then extruding it so that it would go down. Although this is a pretty simple and easy way, instead I could just go to modify, shell, click on this face, and it can automatically create it. And it's just a little bit faster and easier to use. Next, some of these aren't as important. Scaling is useful when you sometimes take a part from another website and it's a smaller or in a different dimension or unit that you originally planned it to. So, and then you can just scale it to however small or large you want. The main, one of the more important tools in this section is the move/copy tool, and it's right here. And the shortcut key is M by default. Using this, I can select an object and move it however I want using these arrow keys to move it up the Y, X, or Z axis. And using this, I can also rotate it using these circular sliders. So by clicking and dragging on these, I can rotate it along the Z, X, or Y axis. And then delete, that's pretty simple. Just select body and then going to delete will delete it. Okay. So I guess next would be looking into how to import custom parts into your workspace and joining them together. So I'm going to use the Actobotics kit of parts as an example. So say I wanted to just get this plate. So to insert it into this workspace, I would first have to save it. And there are a couple ways to do it. The first is over here, the file, there's a save function. You can do that. There's also a quicker save here, or the shortcut is Control S. And then you could just name it whatever you want, depending on whatever the part you want it to be called. So I'm just gonna name it test. Then I'll just, if you have the student version, or I think all of the versions except for the free, like the personal version, you can right click and then it should show a bunch of options. And the one you want to use is insert into current design. Or another way that a lot more people use is just dragging it into the workspace. And then it should just show up like this. And usually I just click OK. But sometimes, for example, just this. If another part is overlapping, it's really simple and you just want to get it out of the way. You can just use the arrow keys or the arrows, which is the move function, to move it out of the way so you can see it at a better perspective. Click OK. And now just say I wanted to connect these two parts. The way I do it is under Assemble, there is a function called Joint. And I could click that. And then there are a bunch of different ways to join parts together. And you're going to have to research that by yourself to see which works best. And even for these two plates, there are a lot of different ways to join it. one way I could do it is by coming here and hovering over this line. You can see that there is a vague white circle where my cursor is. And this is the joint icon. So if I hover over this line, you can also see that there are a couple points on this edge. Like over here in the middle, there's an arrow, and then over here at the corner, there's also a dot. And these are selection points that Fusion 360 automatically generates for you to click to help you in joining pieces together. So say I just wanted to connect these two edges. All I would have to do is hover over this line, click Control, so that even if I slightly move my cursor out of the way, it'll stay onto this line, and click the middle section. Now, because I clicked the middle point, I would have to also click the middle point of this edge so that you can see it's perfectly aligned. But if I chose this point at the end, you can see that it will connect to this point instead. So what joints do is just, it creates a joint point at a random point that you choose, and it connects it to another point that you choose on another part. And then there are still, like I said before, a bunch of different ways that you can create joints. I could also use it on these circles. Like you can see that there is a yellow circle this time. That's just because it's a circle. And if I wanted to connect it perfectly on the edges, I would go over here to select this circle and click that. And you can see that it perfectly aligns automatically. In some other CAD softwares, you need like 2 or 3 points to connect parts together. But in Fusion 360, it automatically tries to do what you think it wants you to do and will help you with only 1 point. Okay. Sometimes when you create joints, it gives a slight problem, which you'll see, which looks something like this. And that's because Fusion 360 sometimes misinterprets what you want it to do. So it's a really simple fix. And over here in the joint drop-down menu, you can see that there's a flip button, and that will usually sort out the problem. But if it doesn't, that probably just means you connected your joints wrong and you'll have to redo them. So even when you create a joint, there is still a move icon here. So you can use the joint to move it after you create the joint by rotating it or just moving it across the X, Y, and Z axis. But you can see that after I join it, if I just select the part and try to move it, it'll move the entire portion. So if I just want to move that section, then I can go under joints, and you can see all the joints you made. So in this case, I only made one. I could select it, right click, and edit joint. And then from there, I can move it just by itself. So let's say you don't want it to just have this plate stay there, like just not moving. You want it to have some action. So in that case, there are different joints that can help you. So if I made another joint, I just selected this middle point and connected it here. So you can see in this joint drop-down menu, right next to the position tab, there is a motion tab. And with this, you can see that there are a bunch of different types of joints. The main three ones that you'll be using throughout FTC or just in general are rigid, revolute, and slider. Rigid just connects two pieces together and it keeps them there. So those parts won't move at all. But if you choose a revolute joint, then you can make that part rotate. And you can change the axis on which it rotates to. And slider just makes the part go back and forth. And same with the revolute, you can change whichever axis you want it to do. And then with this, if I click OK, you can see that there is a joint icon that shows this was made by a slider. And using this, I can slide the part manually to just simulate whatever action it was. So if I had a servo arm here, instead I could create a revolute joint and show the arm going back and forth. There are some more complex functions here, but because of time restraints, I cannot show them to you. Just another really useful tool is the measure tool, and this can measure edges, the distance between two objects, and it's really useful when you're trying to make out those exact measurements. So if I just wanted to measure this edge to see the length, I could click it and it would show up here. If I wanted to find the distance between this edge and this edge, I can show that the distance is 4.572 millimeters. And that's just a really useful tool. But say you don't want it to be in millimeters. You can change that by going to Document Settings, clicking the drop-down arrow. You can see that by default, the units are millimeters. So you can change that by clicking this paper icon, and then from there, change the unit types to whatever. But doing this will only change the units in that specific model. So if I went to a new design, you can see that the units are still in millimeters. So to change it so that every new file you make is in the units you want it to be, you can change it here, going to centimeter. You can click set as default, and then from then on, all the other units will be in centimeters. Another way to do this is go to Preferences, and then you can go to Default Units, Design, and then from there, change it. There's just one more thing that I want to go over. So there are different workspaces in Fusion 360, and these workspaces allow you to do different things. So in the design workspace, this is where you'll be making your custom models or joining pieces together to make your robots or other assemblies. But if you go to like say the render workspace, this is where you can put images or different shadings on your parts to make it look more realistic. Animation will let you animate your different parts, and this is useful for when you're going to be creating simulations of what your robot or whatever object you can do. The rest you won't really use. You won't even use render that much. So the main ones you'll be using are design and animation. I'm not sure if I have time to Okay, okay, so I'll just do a quick overview of how to just animate in Fusion 360. So this is your workspace where you can start animating. So this is your timeline down here, and this is where you can see all of the actions that you do, and even your camera movements are recorded. So if I rotated the camera movement here, you can see that the view is recorded. If I just but say you didn't want to record your animation and you just wanted to move around. By doing that, you can go to this red curtain area, and from there, you can move the parts freely however you want, and it won't change or record whatever you do. But say you wanted to move around in a certain area, because right now, even if you have your cursor in this red curtain area, it'll only show from frame 0. So to stop the view, you can go up over here and click that, and it'll show that the view is not recording. So even if I go say 2 seconds and rotate it, you can see that the view is not being recorded. So now let's get down to actually animating the parts. It's the same as in the design workspace. So if I selected this part, I could go to transform components. And from here, I could move parts up, down, or rotate them, and it'll save it in the timeline. So if I just run that, you can see it automatically did it. But you can see that like the view was only 1 second, while the assembly was 1.5 seconds. So you can change it by just hovering over the edge of the action and dragging it to the specified time. By default, whenever you record, the time is going to be 1.5 seconds. But if you have the cursor only 1 second apart from your last action, then it will only record for 1 second. So what I mean by that is if I here, you can see now that the movement is only recorded for 1 second instead of 1.5 seconds like before. And that's because my slider or my playhead was only a second before the previous action. Something to note is that Fusion 360, when you want to publish it, the animation, you just click publish, just click OK. Usually you save it to your computer so it's easier to access. It takes a while to publish, even if it's only a couple seconds long. And the more you, I guess, add on to your story, the laggier it gets. So it's harder to see what it's actually doing. And just in general, Fusion 360 takes a lot of computing power. So I would advise just maybe close down all other applications if your computer is lagging while running Fusion 360. But that's just something to note. I guess that's all. I went really fast and I didn't go into depth into a lot of stuff. So if you have any questions, please ask them now, because now we're going to have you try following along by creating your own attachment.
Okay, so I guess I'll go through a demo now.
Yeah, okay. Yeah. John's going to demo how to create larger attachments.
Okay. So in this case, scenario, I'm going to like demo making an intake similar to this kind, but like a lot simpler. So let's just suppose that we were supposed to intake a ball of like, say, 8 inches in diameter. Start with a sketch on the top, because the top side, like this 2D dimension, is the most important part for this specific design. So I'm going to say 8 inches, that's the ball. And like that design, I'm going to have 2 compliant wheels here. Actually, I'm going to mirror that, so I don't need that one. So I'm going to say this is 4 inches. And I would like a design similar to, I'm going to make this tangent. So something like this, where it's a curved shape and it holds the 2 wheels and it clamps down on the wheel. So there are a few important dimensions here. For instance, there's so you probably want a certain amount of compression on the ball at all times to keep it inside. So I can do a line here, and I would like to dimension like the distance between here. So I should select these intersections. And now if I make this construction, I can get this line, and I can dimension that. Let's just say that's like 0.1. And then I also want to dimension like the maximum amount of compliance in this wheel, because the size of this, like if it's larger, it won't have as much room to get smaller, but if it's too small, then it won't have enough strength. So I'm just going to say the distance between these two is going to be like something like 0.775. That's a good starting value. And next I want to specify how, like where this wheel is. It's more inwards, it's going to be harder to intake, but like it won't come out. Like, so the ball won't come out, so I'm just going to guess a random number that we can iterate later if we make this. I'm press D for dimension. I want to dimension against this line. I hold down the left click button and I can select this line, yes. And select these 2 lines and automatically chooses to do an angle. I'm just going to say this is 10 degrees. And that's a good starting amount. So next, we probably have to put the motor somewhere. So the motors, you probably want to put them towards the back if this is an intake that's going to be like all moving and stuff, because then the motors like define where the center of gravity is, and we don't want to have to move the motors whenever we move the intake. So I'm just going to do a like 1-stage belt pass. So I'm going to do a slot tool, which is pretty helpful for this. And now we have the basic path. Now, let's just say I have 24-tooth pulleys. I'm going to go to Rev's website. I think I might have it here actually. Okay. Wait, I think I knew. Yeah, here's 24-tooth pulley. I'm going to measure the outside diameter of it. Just copy that by clicking on it. So I want the diameter of this to be that, or it wants radius, so I'll just Control V, I'll say divide by 2. And now we have our belt run. And you want to choose from a belt that's like a commercial off the parts one. So I would just say like, you can guess and check like 122 belt. So I have a very basic center to center calculator. You can find the equations easily online. I just put it into an Excel spreadsheet really quickly. So yes, if I put 120, it would say 144, and everything's in millimeters. So I have to mention the center to center of this to be 144 millimeters. That looks pretty good. Now, we want to make this a construction because that's not important to the shape that we're going to extrude later. So next we want to put a motor at this point. So we need the motor holes, and we want the outside diameter of it just for reference. So I'm just going to get this one. I'm going to click I for inspect. Let's get this diameter. And by putting this here, I'll be able to know if anything is going to be interfering with the motor. I know that the motor has space right now. Next, I'll have to get these holes. So I'm going to put the holes here. I'm going to use this circular pattern tool, and that allows me to save time. Let's say 4, right. And these are M3 holes. So I'm going to dimension them 3 millimeters. So that's through bore. And I'm going to need to find how far apart these are. So this, later we're going to joint these together, and I guess I'll, but the distance between these two has to be really accurate. I set it to the nearest 6 decimal points, or else if it's not that accurate, then the later step will fail. But okay, so now we have this point, and if you can drag it around, you can see how it moves. So we want to save space. So I think having this belt tangent to the outside would save the most space. And we want to put these screws in. Doesn't really matter which where we put the screws in, because as you can see, this belt is going to be interfering with it, so we just have to make it a bit taller to fit the screws in. So there's not really a way we can position the screws to give us an advantage. So I'm just going to say, use my shortcuts, or you can get here. I'm going to say this belt is touching this line, just so that they don't change in the future. And next we need the bearing holes. So that's just these. And for hex shafts, which is what I'm planning to use, these are equal, and I can set this to be 12 millimeters. So now I have the basic structure. I'm going to make this a line here so I can use this as a mirror point. And I'm not going to mirror everything here, so that'd be a lot of stuff to mirror. I'm going to finish the sketch, and I'm going to extrude this. I'm going to, I can press pull, it'll automatically select extrude, because let's just say do 0.2 inches. And I said look at new component, because new components are easier to work with. So, and then we want to put the pulleys in. I'll just insert this one. Wait, from a different project. Shoot. Okay, I guess I'm not going to insert that in then. Well, so this is free moving. So I already have it in the right position because that's how I sketched it out, based on the center of the ball and on the origin. So, but I don't like the height is what I want to have be like determined by other stuff. So I'm going to do an as-built joint where like what's the origin, so that way it automatically gets the positions it is currently. I'm going to say going up and down. So now it can only go up and down. So I'm just going to move this down a bit and capture position just for like, so it's easy to see. And I'm going to do a mirror pattern here because you want both the top and bottom. Right. And these two plates are going to sandwich the pulley and the bearings. So I can't import this. I mean, usually you would be able to, but it's just the way that I created this. I'm going to copy this distance, and I'm going to create, say, do another as-built joint between these two components. And I say, actually, okay, I'm going to do a joint instead. I'm going to say between these 2 points, there is, well, the offset in this direction is, so it's positive. I'm going to say 1.8 millimeters, which is the width of the bearing. I'm going to say 2 times that, because there's 2 of them, and I'm going to say plus the width of the timing belt pulley. So we can just imagine that there's a timing belt pulley in between. And now we have this basic structure. And then, okay, so now we want to import, I guess we can go onto the motors. I'm going to do this motor. Oh, wait. Shoot. Oh, wait, this works. Okay. So what I'm going to do with this motor is explains why I need so much accuracy here. I'm going to do a joint, like, because these holes are kind of like in a wonky angle. So I'm going to do a joint here, but I'm going to kind of mimic like what a screw would do. And I'm going to say it's a revolute joint. Okay. Well, those weren't rigid groups, so I'm going to quickly rigid group all of these first. So now that works, because I jointed them first. So now we have this angle. Wait. Oh, this has to be rigid. Whoops. Okay. So now we have this angle, but it's like, So I'm going to like pretend like I'm screwing in the second part. So, okay, so I see there's I'm going to revert position so I can, okay. So I see there's a joint there, and I want to put a joint in the second hole. And it's going to be on this hole, so I'm going to reveal this thing so I can see. I'm going to say it's right here. And there's already a joint between these components. So that means if the distance between those holes is not like exactly the same, then there will be an error popping up. But hopefully there will not be an error. See, okay, so they're exactly the same. And now this motor is essentially just rigid, like screwed in essentially. And now we're going to put the wheels on. So I'm going to get the wheels. Hopefully they can insert. Okay, that's good. So these wheels have a 1/2-inch hex. So what I'm going to do is, this is going to be a normal Rev 5mm hex shaft, but then Rev also has Ultra hex, which is like converts the 5mm hex to 1/2-inch hex. So I'm going to like pretend I'm putting one inside this bore. So now it's a 5mm hex 4. I'm not going to actually model that right now because it's just for the sake of time. Now, and then you can say a joint on here. And just make that rigid to make it run a bit faster. I'll just say like 1mm offset. Oh, it's the other direction. Whoops. Now if you look at it from the side, that's the amount of clearance that I think I've used before, so I'll just use that. And then, of course, it didn't move it. So before I do that joint, I would like to say like this entire thing is rigid grouped. Oops. The entire thing is rigid grouped. So now if I did that joint, the entire thing would move there. Now I'm going to make a joint. Say, I want to take advantage of the symmetry, like the use of this origin, so I can put the ball as a center and be able to use it as a mirror. So I'm going to create a joint by clicking J. I can select between two faces. So between this face, oh. Okay, I guess I can't do that. I'll just create a midplane then between these two things. And I say, there should be a way to well, I already made a midplane, so I'll just mirror this over this plane component, select this entire thing over this plane. And I already have the second wheel here, but it's not attached. So I want to select an as-built joint so I don't have to specify anything new. I'll select this part and this part. And it's rigid. So now they're... I think I selected the wrong wheel. Huh. I guess... Maybe I'll just do rigid group instead then. That way I can see the components that are being moved, and yeah. Okay, but okay. Oops, I forgot to rigid group the inside part. So now it has all the components in there with our imaginary belt that would work because we did the calculations. Now the final step is to do the mirror. Select, well, we want to select everything basically, and we want to mirror them over this. So now we have our intake. So we mirror them, wait a while, and we want to combine these two because they're currently separate components. So I'm going to do combine tool. Target body is the one you want to stay there. The tool body is the one that gets destroyed basically. Target, yeah. So now I have the intake. Yeah. Well, it's not joined. Wait, actually, I'm going to go ahead and rigid group all of this. Wait. Oh, oops. Just like, so it all moves together because they're, yeah. And so then I'm going to create a sphere to accurately model the ball. Okay, just at the origin, and say it's 8-inch sphere. Say new component, right? And then, well, we want this to be in the middle, not like floating around. Actually, we could we can actually just make a point on this plane instead of using the origin. So it should be one of these. I think this one. Okay, point through plane and edge. So plane and this edge. Now we have a point that's like at the center of this intake, and that's where we want to put our ball. I guess I didn't select the right plane. Okay, I guess I have to make a, wait. Kind of didn't make this very well. I can't, I was planning to do like joint in between faces and then have them jointed to this origin so I could create a sphere here. I guess, I guess for now I can just get the distance between these two. Copy this, select Shift J for as built joint, say this, and just click the origin. Wait. Oh, I have to do a move, yeah. So I do move this thing as I point to position. Point, it should be anything on this plane. That's not. That, no. Yeah, that's on this plane. And we say position Z is that. Oh, that divided by 2. And you want that to be negative. So now, okay, well that didn't update the rigid group for some reason. Oh, I think this slider, yeah, that's where I should put it. Divided by 2. And should be negative. Right, good. So now the origin should be in the middle. Okay, that's some wonky stuff going on. But okay. So now when I create the sphere, what? Oh, I need capture position to keep that. Now when I create the sphere at the origin, at 8 inches, new body, that's basically correct. Now you can see here that this isn't actually going to hold the sphere. That's something I did wrong with the initial design. So now that we've created it this way, we can easily come back to it and just say, loads, which say we want to add like another part here. So now this is the entire design. And we just make this tangent, and we don't want this to interfere with how much compression the compliant wheel has, so we can make them like right here. And now, if we edit the first extrude, we can add this to it. And now it's a good intake. Yeah. Okay. And then if you wanted to put like mounting holes on here, or to make this more 3D, you just add more sketches with like in different dimensions with all the parts you need. Like you could add like holes here for mounting or something. Okay, does anyone have any questions?
So that's the end of your presentation, John?
Yeah.
Okay. So now if nobody has any more questions, then I think we can begin the drawing. Okay, so I think I can stop the